So today we're going to learn how to divide a polynomial by a polynomial. Before we get into the rules, however, let's simplify these first two problems that are pretty simple for us to simplify. So we would just follow the order of operations. Now when you have a fraction bar, you know you have to do what's on the top and what's on the bottom and then do your division. So if I'm going to go ahead and multiply the top, 8 times 2 is 16, and 16 times 4 is 64. So on the top, I'm going to have a 64. And then on the bottom, we're going to do 4 times 6, which is 24. And then if you think about this, we can reduce this. If I look at 64 and 24, both of those are divisible by 8. So I could divide by 8, and I would get 8 over 3. And so this answer would be 8 over 3. Pretty simple. We know how to do that. The next one, it's addition. So suppose I'm doing 8 plus 2 plus 4. Well, 8 plus 2 is 10, and 10 plus 4 is 14. And then the bottom would be 4 plus 6, and 4 plus 6 is 10. So I have this improper fraction, 14 over 10. I could reduce that by dividing the top and the bottom by 2, and that would give me 7 over 5. And so if I look at these problems again, the question here is, will I get the same answer if I cancel numbers first? So we have learned that we can do some things called cross-canceling, especially with multiplication happening. So if you take a look at this next problem here, there's lots of different ways that I could cancel things out. So I'm already noticing here I've got an 8 and a 4. So at the top, I could reduce 8 over 4 first, and 8 over 4 reduces to 2 over 1, right? And then I can look at the 2 and the 6 and the 4 and the 6, and I know, well, 2 goes into 2 and 6. So let's look at 2, 6. I could make that a 1 over 3. So now what I can do is I can just multiply 2 times 1 times 4. Oh, well, that gives me 8. And at the bottom I have 1 times 3, and that gives me 8/3. So what we did here, we got the same answer, right? We went ahead and we just canceled numbers first. We reduced before we added, or before we multiplied, and we got the same answer. The question is, will that work with addition? So let's go ahead and just look. What if I canceled 8 and 4 just like I did before, and I made this 2 and 1? And then this 2 and the 6, what if I made that 1 and 3 again? And then because it's addition now, this is 2 plus 1 plus 4. So 2 plus 1 is 3, and 3 plus 4 is 7. And then the bottom would give me 1 plus 3. Well, 1 plus 3 is 4. So my question now is, well, is that the same answer? And here, these guys are not equal, right? This is the correct answer. This is the correct way to do it. We had to follow the order of operations. So my question here is, will I get the same answer? Well, I will only get the same answer if it's multiplication on the top and the bottom of the fraction bar. If it's addition and subtraction, we can't cancel. So my conclusion here is canceling only works with multiplication. You cannot reduce between addition or subtraction signs. Now, the reason that we go over this is because this is going to help us when we start dealing with dividing a polynomial by a polynomial with variables. So let's take a look at the problems below. So the first one, 12/18. If I were to say simplify this, well, we would look at 12/18 and say, all right, I know that 12 and 18 are divisible by 6, and 12 divided by 6 is 2, and 18 divided by 6 is 3. So that's just reducing a fraction like normal. Now let's just for a second just take a look at why that's allowed, right? If I were to break up 12 into 6 times 2, and 18 into 6 times 3, well, we can see here that the 6's cancel out. So it's just another way of looking at it. So the answer is 2/3. And it's true also when we've got variables. If you look at this next problem, you know that these A's represent the same number, so I can cancel them out. And these C's represent the same number, so those cancel out because they are equal to 1, right? And so what I'm left here with is a B. That's all I have, B over 1, which is just B. If I look at C, you can cancel out the X's that are here because they represent the same number. You can cancel out the Z's that are here because they represent the same number. And because what we have left now is WY over V, we can't do any more canceling because WY and V all represent different numbers. So now let's take a look at D. What I have here is I have x plus 2 times x minus 3 over x minus 3 times x plus 2. Now if you think about, because x plus 2 is being multiplied with x minus 3, and same at the top and the bottom, we can cancel out this entire polynomial, x plus 2, and this x plus 2 are going to represent the same number, and they're being multiplied by the other set of parentheses. So we can essentially cancel these guys out and say that those are equal to 1, because x plus 2 divided by x plus 2 is going to give me 1, and that's going to be true here. This x plus 3 and this x plus 3, they're going to cancel out because they're equal to 1. So this polynomial simplifies simply to just the number 1. E, the next one, is basically the same. This polynomial 4x plus 3 is the same as this, and because these things are being multiplied together, these guys can cancel out. Since the 4x plus 3 is being multiplied by 3x minus 1, they cancel out. So this 3x minus 1 and this 3x minus 1 represent the same number. So essentially, this is going to be the same number times the same number over the same number times the same number, which is, again, going to reduce to 1. So now moving right along to letter F, if you go ahead and take a look, all of these guys are being multiplied together. These are polynomials being multiplied by other polynomials divided by more polynomials being multiplied by other polynomials. So what we're doing, because they're all being multiplied together, this x plus 4 and this x plus 4 right here, these guys will end up being the same number, right? So we know since they're going to be the same number, we can cancel them out to equal 1. And then if you look here, this 5x plus 3 and this is 5x minus 3, these will not give us the same number, right? 5x and 5x will give us the same number, but you have to add 3 here first, and then here you would have to subtract 3 before you're allowed to divide. So these guys don't cancel out, so we can't cross those out. But these two, x minus 1 and x minus 1, because these guys will definitely give me the same number, these will cancel out. So my answer here would be 5x plus 3 over 5x minus 3. Now, you have to stop there. The reason you have to stop there is, taking a look at what we just did up top, we learned that we cannot cancel things out that are being added and subtracted together. So like, you might be tempted to say, well, this 5x and this 5x will give us the same number, so we should be able to cancel out, and then these two would reduce to -1, but that's not going to work, because the order of operations says I have to do 5x plus 3 before I divide it by 5x minus 3. So you would have to do this, and then divide, which won't give us the same answer if I cancel this out first. So this is the correct answer to this one. All right, now moving to the next one. The next one, if you look, none of these actually look like they're going to give us the same number. But what we can do here is we can say, well, are any of these factorable? Remembering that the first step to factoring something is pulling out the GCF. So let's just take a look at 8x plus 20 for just a second. What is the GCF of 8x and 20? Oh, that's 4. So let's take that 8x plus 20 and let's pull out a 4. So I pull out a 4, I take 8x divided by 4, and I get 2x plus 5. And then the next one, 6x minus 9, well, let's take a look at that. The GCF of 6x and -9 is 3, so I'm going to pull out a 3, and it's all still being multiplied together. I pull out a 3, and I'm going to get 2x minus 3. All right, so now let's look at the bottom. The bottom, 6x plus 15, it does have a GCF of 3, so I can pull out the 3, and when I pull out the 3, I'm left with 2x plus 5. And then the bottom, 2x minus 3, well, there's not a GCF there. That's 2x minus 3. So now what I can do to fully simplify this is I'm looking for the same numbers, right? Well, let's look. This 3 and this 3 will cancel out. 3 divided by 3 is 1. And then this entire 2x plus 5 is the same as this entire 2x plus 5. So the 2x plus 5s will cancel out. And then these two 2x minus 3s will cancel out. So you have to keep in mind that the 2x minus 3s inside parentheses, they are the same number because you would do what's in parentheses first. What I have left over is the 4. This entire thing, who would have known from the very beginning that this entire thing is just equal to the number 4. Let's take a look at h. So looking at these now, none of these sets of parentheses will produce the same number, okay? Keeping in mind if I were to do this and this and this, we don't know right now what numbers those would produce. However, there are GCFs here. If you look at the GCF of 24x to the 4th and 40x squared, well, for 24 and 40, I could pull out an 8, and they both have x squared in common. So I'm going to pull out an 8x squared, and then I divide each of these by 8x squared, and I'm going to get 3x squared plus 5. Now the bottom, let's look at the bottom. In the 4x to the 3rd plus 12x, I'm going to pull out my GCF. My GCF is 4x, so let's pull out a 4x. Just the first set of parentheses is what I'm looking at there. Divide everything by 4x, I'm going to be left with x squared plus 3. And now let's look at 10x minus 15. Well, I can pull out a 5 there. So if I pull out a 5, whoops, I'm going to sneak that little 5 in there. If I pull out a 5, I'm going to have 2x minus 3. So now let's take a look at what I have here. If I look at my sets of parentheses, this one, and this one, these are all different. These are all representing different numbers. We can't cross anything out here. However, the stuff on the outside, we could reduce that because this is one term divided by one term. We could cancel some stuff out here. So here, this 8 over 4 is just going to become a 2, and then the x at the bottom is going to leave me with an x at the top. So all of this right here is 2x on the top. And then I have this 3x squared plus 5. And then on the bottom, I'm going to bring this 5 out to the front. So I have a 5, and then the two sets of parentheses, x squared plus 3 times 2x minus 3. And now we are finished with this problem. This is the simplest version of this big crazy polynomial. So the whole idea here is we're trying to figure out what can we cancel out. So now let's make a conclusion here about how to divide a polynomial by a polynomial. Again, what makes something a polynomial is that there are more than one term, right? So what I'm talking about here is if I have more than one term divided by more than one term. What you have to do is you have to factor the top and the bottom and then cancel out common factors. And I'm going to explain what I mean by that in just a minute. So we factor the numerator and the denominator and cancel common factors. So essentially what we've just done in these top 3 problems here, these guys are polynomials that have already been factored, except here we had to pull out some GCFs. And the reason we're allowed to cancel these guys out is because we know they're going to be the same number because they're all being multiplied together. So now let's take a look at the next set of problems. So now if you take a look at number 1, you might be tempted to start canceling numbers out. You might be saying, okay, well this 2x squared and this 4x squared have a common factor of 2x squared, so I'm just going to divide these by 2x squared. But that's totally illegal. The reason that's illegal is because, remember, you would have to add all of this first and then subtract and then divide. Because there's addition and subtraction signs, we can't do that. However, if I factor it, then I can cancel out any common factors. So if you take a look at the top here, this top, the first thing I'm going to ask myself is there a GCF? And there's not, because there's nothing that will go into 1x, right? Or 2 and 15, actually. So now what I'm going to do is just let's break this into binomials, right? So let's start breaking it up. Looking at the first term, 2x squared, the only way I can break up 2x in x, or 2x squared is 2x in x. And now let's taking a look at negative 15. So since I know that it's going to be a positive and a negative, because it's the only way to get negative 15, I'm just going to put my plus and my minus here first. I might be wrong. And let's go ahead and say, well, 15, factors of 15, 3 and 5. Let's go ahead and try 3 and 5. And now I'm just going to do my inners and my outers. I'll erase this in a minute. So let's just see if I'm doing it right. So I've got negative 3x, and my outers here give me 10x. And if I do that, negative 3x and 10x, well, that's going to give me 7x. So that's not going to work. So I got rid of my check here, and now let's just switch my 5 and my 3 and see what happens here. So if I put the 5 here and the 3 here, well, this is going to give me negative 5x, and this is going to give me 6x. And negative 5x and 6x does give me x. So I factored the top correctly. So let's go ahead and erase this, and then let's look at the bottom. The bottom is so much easier to factor because at this point, hopefully you have noticed, it's a binomial. So it's a perfect square minus a perfect square, meaning I'm trying to get 0 in the middle. All binomials will break into a difference of squares. So this is going to break into 2x plus 5 and 2x minus 5. And so now if you take a look, the 2x minus 5's, this 2x minus 5 and this 2x minus 5, they will represent the same number. And since that set of parentheses is going to be done before multiplication of the other set of parentheses, you can cancel them out because you're allowed to cancel things out between multiplication. What you're left with is x plus 3 over 2x plus 5. And you're done. You can't do anything else with that because it's fully factored. There's no more multiplication happening between terms, so you can't cross anything else out. And that is your most simplified answer. So let's go ahead and take a look at number 2. Now number 2, automatically you might look at that and try to cross out x's and 5's, but you can't because the subtraction sign. So I have to factor. So looking at the first step, is there a GCF? So looking at x squared minus 5x, don't forget, variables are GCFs as well. So in the top, I can pull out an x. And when I pull out that x, I'll be left with x minus 5. And then on the bottom, well, 5x minus 25 might not look like it's factorable, but there's a GCF. The GCF there is 5. So you always have to remember to try to pull out GCFs if you have that, always. And when I pull out the 5, divide everything by 5, and you are left with x minus 5. And so what just happened is that these two factors, x minus 5, represent the same number, so they cancel out to give me 1, and what I'm left with is x over 5. Finished. Now let's take a look at number 3. Number 3, you might be tempted to cross out the x squareds and the 12s, but that's totally illegal because you can't cross things out between addition and subtraction. So we factor it. So let's go ahead. This should be a pretty easy one to factor. The top, I'm going to break up x squared. The only way to break up x squared is x and x. And then 12, I've got factors that could be 6 and 2, 4 and 3. I already know that it's going to be 6 and 2 because 6 plus 2 is 8. If you think about it, your inners, I'm not going to write it down, your inners are 6x, your outers are 2x, and 6x and 2x give you 8x. So that's the top. And then the bottom is going to break into x squared, we can break that into x times x, and 12, I can do 6 and 2 again, but that's not going to work because that gives me 8x in the middle, so we got to try other factors, 4 and 3. And I know it's 4 and 3 because 4 plus 3 is 7. So that kind of factoring is easy, remember, when the first term is just an x squared. 4x and 3x gives me 7x. Now if you look, none of these factors will end up giving me the same number, so we're done. We're going to say this is the answer. Right? All right, so let's go ahead and try number 4 together. So for number 4, again, we can't cross things out between subtraction signs. So if you look, this binomial, the first thing you ask yourself, is there a GCF? There's not, but x to the 4th is a perfect square. 81 is a perfect square. We can break x to the 4th, and you haven't done one like this yet, I don't think. You can break x to the 4th into x squared and x squared, because it's an x squared times x squared x to the 4th. And then 81, you have to break that into 9 and 9 And because you're trying to get 0 in the middle, it's going to be minus 9 and plus 9. And now the bottom doesn't have a squared variable, but yes, there is a GCF. It's 3. So I'm going to pull out the 3, and when I pull out the 3, I'm going to be left with x minus 3. So now looking at this, it doesn't look like I have any common factors. However, you've never done a problem like this yet, so hopefully you're still listening. Look at this factor right here, x squared minus 9. This is a binomial. It's still a perfect square minus a perfect square. So this guy right here can break into x plus 3 times x minus 3. So I'm going to break this into, this guy right here becomes x plus 3 times x minus 3. Now we can't break up x squared plus 9, right? Because we learned that x squared plus 9 doesn't work because it's addition, right? You can only break something into a difference of squares if it's a perfect square minus a perfect square. So x squared plus 9 we can't touch. The bottom stays 3 times x minus 3. And so now we do have some common factors. This x minus 3 at the bottom will cancel out the x minus 3 at the top. And then what you're left with is x plus 3 times x squared plus 9 over 3. All right, so if you're feeling like this is pretty easy for you, then go ahead and stop the video and try 5 and 6 on your own, and then come back and you can just kind of fast forward the video to see if you got the final answer. A clue about number 5 is that there's going to be a similar binomial that factors twice in number 5. If you are still feeling a little iffy about this, stay tuned and I'll just explain. So taking a look at number 5, I can't actually pull out a GCF on the top at all. There isn't one. So let's go ahead and just start factoring it. I know my signs are going to be the same because of the plus 9 at the end. The signs are different, or are the same, and I know that my signs are going to be minus, minus. I'm going to go ahead and try 2x minus 3 and 2x minus 3. And if you take a look, my inners and my outers, I'm going to get negative 6x and negative 6x, which is going to give me 12x. So I'm going to leave that. That's right, 2x minus 3. Now the bottom is a perfect square minus a perfect square. So I can break that into a difference of squares. So 16x to the 4th becomes 4x to the 2nd times another 4x to the 2nd. And then negative 81 factors into minus 9 and plus 9. Now taking a look at this, it still doesn't look like we have common factors. However, this is still a perfect square minus a perfect square. So that one right there can go further. So my top, I'm going to leave as 2x minus 3 times another 2x minus 3. 4x squared minus 9 breaks into 2x minus 3 times 2x plus 3, because that's a difference of squares. And then 4x squared plus 9 will not factor because it's addition. And so then, if you notice, I have a 2x minus 3 on the top and a 2x minus 3 on the bottom that I can cancel out. And my final answer is what's left. I have 2x minus 3 on the top over 2x plus 3 times 4x squared plus 9. And we're done. That's my answer. This next one looks very complicated. Many people will get this one wrong because they will forget to pull out GCFs. In number 6, the top one has a GCF. The GCF is 2x, so I'm going to pull out the 2x. And when I pull out the 2x, I'm going to be left with 9x squared plus 6x plus 1. The bottom has a GCF. The GCF is 4y. When I pull out 4y, I'm going to be left with 6x squared plus 11x plus 3. All right, so I slid that right on over real fast just to make sure that I have enough room here to do this problem. And so now let's factor this further. I am noticing right away these monomials, you can cancel out monomials because those monomials are now being multiplied. So we can right now reduce the 2 over 4, or the 2x over 4y, to just x over 2y. I just divided by 2. All right, so now we're going to factor the top into, I'm going to try 3x plus 1 and 3x plus 1. And I know that that works because my inners give me 3x and my outers also give me 3x, and 3x is 6x, so I know I did that right. So now when I do 6x squared plus 11x plus 3, I'm going to keep in mind I have a factor of 3x plus 1 on the top, so I bet you when I go to factor the bottom, there's going to be a 3x plus 1. I'm just going to start with that. I might be wrong, but I bet there is. So when I go to break up 6x squared, I'm going to do 3x and 2x. And when I go to break up the 3 at the end, I'm going to do 1 and 3. And the reason I'm going to do 1 with the 3x plus 1 is because I already have a 3x plus 1. So now let's check my inners and my outers, right? My inners here give me 2x. My outers give me 9x. And 9x and 2x does give me 11x. So I factored it correctly. The 3x plus 1s will cancel out completely. And on the top, I'm going to be left with an x times 3x plus 1 over 2y times 2x plus 3. Now I want you to stop the video, and I want you to try the next several problems that say now you try. And I've created a separate video for you to tune into to check to see if those answers are correct. Good luck!